Assalamu alaikum, dear students. How are you? I hope you are well. I am also well by the grace of Almighty Allah. Today I would like to take class on Bangladesh and Global Studies for class 9, chapter 3, lesson 3.3, topic the motion of earth. After the end of the lesson, you will be able to explain the concept of diurnal motion, annual motion, and you will also be able to explain the reason of increase and decrease of day and night, and you will also be able to explain the cause of change of seasons. Dear learners, before going to today's lecture, I would like to revise the previous lesson in brief. The round-shaped Earth orbits on its own axis from west to east regularly. As a result, different parts of the Earth's surface face the Sun at different duration. When the Sun is just overhead at a place, midday occurs there, and it is 12 noon over there. The Earth rotates from west to east, so the Sun rises earlier in the countries locating in the Eastern Hemisphere. If it is 10 a.m. at a place, time at 1 degree meridian east will be 4 minutes more than that of the place. And if it is 10 a.m. at a place, the time at 1 degree meridian west will be 4 minutes less than that of the previous time. When it is 8 p.m. in Greenwich 0 degree meridian, the time at 15 degree west meridian will be 1 hour less, that is 7 p.m. And when it is 8 p.m. in Greenwich 0 degree meridian, the time at 15 degree east meridian will be 1 hour more, that is the time will be 9 p.m. Now, today's lesson. First of all, the motion of the Earth. The Earth has two types of motion, annual motion and diurnal motion. Now, diurnal motion. The Earth rotates on its own axis from west to east regularly. It rotates in this way almost 24 hours. The exact time for one complete rotation is 23 hours, 56 minutes and 4 seconds. This motion of Earth is called diurnal motion. The time for one complete rotation of Earth is called a solar day. The day and nights come due to diurnal motion. During the rotation of the Earth, the part where the sun rays fall in day occur there, and other part remains dark. The time can be calculated due to diurnal motion. Dear students, look at the figure. It is Earth's rotation. The Earth rotates on its own axis from west to east. Now, annual motion. The Earth revolves round the Sun continuously from west to east through a semicircular way. Such movement of Earth is called annual motion. The Earth moves round the Sun in a speed of 30 km per second. The time required for the Earth to make one complete rotation around the Sun is 1 year. This 1 year is called solar year. A solar year is calculated on 365 days. For every fourth English year is calculated on 366 days. Such year is called leap year. Due to diurnal motion, the increase and decrease of day and night happen. Moreover, changes of season happen for annual motion. Now, the regions for which days and night become longer and shorter. Dear students, have a look at the figure. While moving round the Sun, 4 positions of the Earth have been specified in the orbit, such as 21st June, 23rd September, 22nd December, and 21st March. June. While moving round the Sun on 21st June, the North Pole inclined mostly towards the Sun, and the South Pole goes farthest from the Sun. On this day at 12 noon, the sunlight falls over 23.5 degree north latitude, that is Tropic of Cancer, lengthwise or vertically, that is at an angle of 90 degree. The day on 21st June becomes longest in the countries of Northern Hemisphere, and night becomes the shortest. Opposite condition prevails in the Southern Hemisphere. The day lasts for 24 hours in the Arctic Circle, that is from 66 point north to 90 degree North Pole, and night occurs for 24 hours in the Antarctic Circle, that is 66.5 degree south to 90 degree South Pole. 21st June is called summer solstice. Dear student, look at the figure. On 21st June, the northern hemisphere of the Earth, northern pole of the Earth, comes nearer to the Sun. That's why the sunlight falls through Tropic of Cancer, that is 23.5 degree north latitude. On this day, day is longest in the northern hemisphere and night shortest. On the other hand, in the southern hemisphere, night longest and day shortest. Now, 23rd September. While 21st June becomes over, the North Pole starts to go away from the Sun, and the South Pole continues to draw near the Sun. As a result, day gradually becomes shorter in the northern hemisphere and night becomes longer in the northern hemisphere. And in the south hemisphere, day gradually becomes longer and night shorter. In this way, on 23rd September, both north and south poles remain equal distance from the Sun. On 23rd September, both north poles and south poles keep equal distance from the Sun. The sunlight falls lengthwise towards the towards equator and toward both Arctic and Antarctic circles at 66.5 degree and towards the poles at an angle of 0 degree. For this region, day and night on this day remain equal across the earth. It is called autumnal equinox. Dear student, look at the figure. Look at on 23rd September, the sunlight falls through equator. As a result, North Pole and South Pole gets equal sunlight from the sun. Consequently, day-night become equal in the countries of Northern Hemisphere and Southern Hemisphere. December 22nd. After 23rd September, the North Pole continues to move further away from the sun and South Pole comes nearer to the sun. As a result, daytime gradually becomes shorter and night becomes longer in the Northern Hemisphere. In this way, on 22nd December, the South Pole approaches to the nearest position towards the sun. The sun rays falls lengthwise towards 23.5 degrees south, that is through Tropic of Capricorn on this day. On this date, day becomes longest and night shortest in the South Hemisphere. Opposite condition prevails in the Northern Hemisphere. 22nd December is called winter solstice. Dear student, have a look at the figure. On 22nd December, the South Poles come nearer to the sun and North Pole goes away farthest from the sun. As a result, the sunlight falls through the Tropic of Capricorn, that is 23.5 degrees south. That's why day become longest in the countries of Southern Hemisphere and opposite condition prevail in the Northern Hemisphere. After December 22, the North Pole gradually draws nearer to the sun, whereas the South Pole moves away from the sun. For this, day continues to be longer and night shorter in the Northern Hemisphere. At last, on 21st March, both poles remain equally away from the sun. Like 23rd September, day and night become equal across the earth on this day. This state of earth is called vernal equinox. Dear student, look at the figure. This is similar to 23rd September. What we learned on 23rd September, both North and South Pole keep equal distance from the sun. Similarly, on 21st March, both North and South Pole keep equal distance from the sun. As a result, day and night become equal all over the earth. Now, season change. Dear student, look at the figure. On 21st June, the North Pole comes nearer to the sun, while the South Pole goes farthest away from the sun. Day become longest in the Northern Hemisphere, night shortest, while opposite condition prevail in the Southern Hemisphere. During this time, as the North Pole comes nearer to the sun, the North Pole gets more heat from the sun and the air in the North Pole becomes hot. As a result, summer season prevail in the Northern Hemisphere and winter season prevail in the Southern Hemisphere. 1.5 months earlier, 21st June, and 1.5 months later, 21st June, that is for these 3 months, summer season prevail in the countries of Northern Hemisphere while winter season prevail in the countries of southern hemisphere. Now, autumn in northern hemisphere and spring in southern hemisphere. Dear students, look at the figure. On 23rd September, both north and south pole keep equal distance from the sun, and day night become equal all over the earth on 23rd September. But 1.5 months earlier and 1.5 months later of 23rd September, it is autumn season in northern hemisphere, while in the southern hemisphere there is spring season. Dear students, look at the figure. On 22nd December, the south pole comes nearer to the sun and north pole goes away, farthest away from the sun. During this time, the south pole gets more heat from the sun, day become longest. As a result, the year become hot in the countries of southern hemisphere. During this time, in the southern hemisphere, summer season prevail, while in the northern hemisphere, it is winter season. 1.5 months before 22nd December and 1.5 months later 22nd December, for this 3 months, winter season prevail in the northern hemisphere, while it is summer season in the southern hemisphere. After 22nd December, the north pole again come nearer to the sun and south pole goes farthest away from the sun. In this way, on 21st March, both north and south pole keep equal distance from the sun. But 1.5 months earlier than 21st March and 1.5 months later 21st March, it is spring season in northern hemisphere, while autumn season in the southern hemisphere. Dear students, look at the figure again. On 21st March, both north and south pole keep equal distance from the sun, but 1.5 months before 21st March and 1.5 months later 21st March, for this 3 months, it is spring season in the countries of northern hemisphere, and it is autumn season in the countries of southern hemisphere. Dear students, there is homework for you. Look at, complete the individual work given at page 67 of your textbook. Question number 2. Answer the creative question 1D at page 73. Answer the creative question 2D at page 74. And answer the creative question 4D at page 74. Dear students, stay home, stay safe, study regularly, pray for me, keep attached to me for the next lecture. Allah Hafiz. Assalamu alaikum wa rahmatullah.